Hi everyone. I've put together a visualization to help students understand the ROC curve, and that's something that they will definitely encounter when they're doing classification. And I think the ROC curve can be pretty hard to understand. And in my opinion, the reason for that is that it's a parameterized curve, but that's not necessarily pointed out or highlighted in the explanations that you see. So we'll get to that in a second. But what I have here is what I had before, the confusion matrix and this same visualization. You can work with a set of new points if you want. But in this case, the number of points is always the same. So we always have 100 red points and 100 blue points. And then you can set the threshold like before. And remember, the threshold is what determines whether you classify something as red or blue. So if it's 5.26, if an individual has a score less than that, we classify as red. Greater than that, we classify as blue. The difference here is that I have a second slider, and that allows us to move the samples away from each other, or they can be closer to each other as well. All right, so we're going to see what that does down here when we look at the ROC curve. So now let's move down and take a look. So the ROC curve is over here, so I'll explain that in a second. But I have this other plot that I put together for students to look at first so that they will understand this curve better. So let's see what this one is telling us. So what I'm going to do is I'm going to move the samples away from one another. And this is the best possible situation we could have, because it means that this test is a really good test. It lets us distinguish between the red and the blue. If this were the case, then our test would basically be useless, because we can't, this numerical value is not really telling us whether or not it's a blue point or a red point. So let's start with this. Okay, and I'm going to move the threshold all the way down to the left here. And then let's look at the red plot here, the red line. And what that represents is how we accumulate the red points as we go from left to right. So the percentage of red points that we pass. So as we start, we don't have any red points, and there's a red point actually behind these blue points here. But that's why we're staying at 0 there. But once we start to accumulate, you can see the red point starts to move up. And so here the red point is following the curve, and here I'm just having it go up the y-axis, but they have the same y coordinate. They both represent the percentage of red points that we have passed by. So once we are past all of them, then we're up here at 1. Okay? And then it's the same for the blue point. The blue point, right, this blue point staying there because we haven't passed any blue points yet. This one is just on the x-axis. It hasn't moved up yet. The points will start to move up when we start to accumulate the blue points. Okay? And this is a great situation because if you look at the y-axis here, the red point makes it all the way to 1 before the blue point even starts, which means that the two samples are completely separate from each other, which is the best possible situation. Now, to move over to the ROC curve, what is that? Well, basically it's built from this. So notice that the x-axis right here it's really the same as this slider, right? And it's the same as this right here, this x-axis. So when the ROC curve is made, this is just made to disappear. Okay, it's just in the background there, and you don't see it. And now look over here at this y-axis. What we do when we make the ROC curve is we give each of these points their own axis. So we can leave the red point on the y-axis over here, but then we can give the blue point its own axis down here, make it the x-axis. So notice that it's now 0 to 1 on both sides because these points represent percentages, right, of points that we've passed over. Okay, so let's look at this curve over here now. Just ignore the black point for a second. I'll explain that, but the red point is behind the black point there. And so it's just doing what the red point does over here. All right, it's going, and it hits 1, right, and then it stops. And then the blue point, once it gets going here, it does the same thing here, but it goes this way. Okay. All right. So it's really just this on 2 different axes. And then the black point is controlled by the red and the blue points here. So its height is given by the red point, and how far it is side to side is given by the blue point. All right, so we have that, and this is a great situation, right? Because the black point does not start to move this way until we hit 1, which means that these 2 samples are separated. Okay, so this ROC curve is absolutely the best that you can get. But it's interesting to see what happens now if we let them overlap. And then we get something like this. And the reason that this is happening here is because of the overlap. We're going to be passing the red and the blue points at the same time. So that means that the red and the blue are moving at the same time, which moves the black point over this way. Okay? It doesn't go up and hit 1 first, right? So it's moving in the y and x direction at the same time. And you can see now that this would be the best situation. That ROC curve represents total separation of the samples. And as you move this way, the worst would be if it's just a straight line, which means that even from the get-go, right, the blue and the red points are moving at the same time, which is bad. So your model is best if you have an ROC curve that's sort of where the corner is pushed way up here towards this 1. And that's where the AUC comes in as well, right? So the AUC is area under the curve. So the greater the area, the better your test is. And then finally, it's good to make note of what this elbow here represents. It represents the area of overlap. So let's move it down here a little bit more. Okay. So now, as I'm moving left to right, it wouldn't make sense at all to set the threshold here, because I could move it over a little bit more and have more successes without getting any more failures. Okay, so it doesn't make sense to stop the threshold before you start making mistakes. But that point is the beginning of the elbow here. And then the elbow is where the overlap is. And then once you're past all the blue points, it doesn't make sense to go any further, really. I'm sorry, once you're past the red points here, it doesn't make sense to go any further, because then you're just making mistakes. Okay, so the blue points, the beginning of the blue point, right, starts here. This is the first part of the elbow, and the elbow ends then right here. So it defines the overlap. So you want to set your threshold somewhere in here, and where you set it then depends on the kind of mistake that you're willing to make. So if making a mistake with a red point is more serious, then perhaps you want to make your threshold more towards this, right? Because you're getting a lot of red successes here, and you might not care that much about making a mistake with the blue points. Or vice versa, maybe down here. Okay? But hopefully that clears up what the ROC curve is. And what I mean by parameterized is that what's controlling this this path is really this x-axis. Okay, it's a parameterized curve because both the x and the y coordinate are dependent on a third independent variable, this x, this threshold that's sort of in the background here. And I think that's what makes it confusing. So anyway, that's that. And I mean, so far I've really only been doing classification. I haven't done logistic regression at all. So I do have to get into that. So I'm going to start with getting into that in the next video.